All right. So today we're going to be talking about transformations. Okay. We are in section 2.1. 2.1, the whole title was transforming linear functions. We've spent a little bit of time on 2.1 just talking about graphing linear functions. But now we're going to start talking about the transformations. So let's go to work. I'm going to give you everything that there is to know about transformations, and it's going to be a lot. And then I'm going to pare it down and tell you that only the couple things that I need you to grab right now. Okay. One thing that's difficult to talk about with transformations is it's hard to see some transformations visually with linear equations. So I basically have two big areas that I want you to grasp, and then as long as you get those couple things, we'll be good. So anyhow, I'm going to share everything with you and then kind of pare it down for you. So what are transformations? Transformations are reflections, translations, rotations, dilations. Wow, that's a lot of big words, aren't it? Okay. The two we're going to worry about today, well, three that we're going to worry about now is a translation. Anybody know the short word for translation? A what? Yes, a translation is just a slide. We're going to take a graph and we're going to slide it. Okay. The next one is a dilation. A dilation is where we stretch or shrink something. We make it bigger or we make it smaller. Okay. And the final one we're going to worry about is a reflection. Okay. Where you flip flop it or mirror it across something. Those are the three ones that we're going to worry about. Okay. So here are the 5 transformations that we're going to deal with. Now, I say 5, I just said 3, but really all we're going to worry about is whether it's happening horizontally or vertically. Horizontally or vertical. Okay? You'll notice that the top 2 here, a vertical translation and a horizontal translation, those are just a shift or a slide. I could translate each one of you around the room just by moving your desk, right? It's just a slide. The next 2 things we'll learn about is a vertical or horizontal dilation. And the final one will be a reflection. And the reflections are considered to be over the x-axis or over the y-axis. Now, as we deal with the reflections, I want you to notice these words that I have here. Vertical. Whoa. Let's not do that. Let's try that. A vertical translation and a vertical dilation. Let's think about a reflection. If I were reflecting something over the x-axis, what direction would that move?
Right. Or wait, no. I mean up or down.
Up and down. What is that? Something that's moving up or down. That is vertical. Okay, so I want you to put that right underneath there. If we're reflecting something over the x-axis, that is, vertical. If we reflect something across the y-axis, that would be horizontal. And the first thing I want you to get about horizontal is all horizontal movements are on the inside. Okay? And all vertical movements are on the outside. All vertical movements are on the outside. All horizontal movements are on the inside. So, inside, outside. Put your hands in front of you. Remember how we do X, Y, input, output, right? Let's add inside, outside, inside, outside, inside, outside, inside, outside. The first thing I want you to know is any transformation that happens inside a set of parentheses is going to be a horizontal transformation. Any transformation that happens outside of a set of parentheses is going to be a vertical transformation. That's the number one thing I want you to get out of this. Okay? So, let's look at this right here, number 20. Now, you don't know what the transformation is yet, and that's okay. But whatever's happening to that function, that function f of x, whatever's happening to it, is it happening on the inside or the outside? So you said inside. Is that 2 inside the parenthesis? No, so it's outside. So that makes it a vertical transformation in some way, shape, or form. I'll show you how or what the transformation is in a second. But because that 2 is on the outside, we know it's vertical. Are you with me? Let's look at, this one. What's inside? A -1, right? It's on the inside. So what kind of transformation is that? Horizontal. Are you with me? One more. How about this one? G of x plus 5. Inside or outside? Outside. So it's a vertical transformation of some kind. So we're good with vertical or horizontal. Inside, outside. All right. Now, vertical transformations happen as expected. And there's 2 different things that can happen. One, you can simply add or subtract a number. And if you add or subtract, that is a translation. Or just a slide. So if I have f of x plus 3, whatever the graph was originally would simply move up 3 units. Just like if I had f of x minus 2, whatever the graph is, whatever the function is, would move down 2 places. It would just slide. Doesn't get any bigger, doesn't get any smaller. It just slides up and down. Are you with me? So the first type of transformation is a translation, and it happens when you add or subtract. The second type of transformation is a dilation. And a dilation happens when you multiply. When you multiply. So if I multiply something by 3, it's going to make it bigger or stretch it. If it happens on the outside, it would be a vertical stretch. If it happens on the inside, it would be a horizontal stretch. Now, when it comes to stretch or shrink, what I need you to know is that a large number, in other words, a number bigger than 1, is a stretch. Whereas a number that's a fraction or a decimal, that's between 0 and 1, is a shrink. The final reflection or transformation we're going to deal with is anytime we have a negative. Anytime we have a negative, that becomes a reflection when you multiply by a negative. You end up with a reflection. I'm pausing, waiting for you guys to get finished with writing that down because I want to go through an example here. You ready? Okay. Let's say I have a function like this. That's the parent function of a quadratic. It's a very simple form. Are you with me? Okay. If I take that function and I add 3 to it, it looks like this. X squared plus 3. Okay. The graph of the original function looks like that. The transformation of the function means that I'm just going to do what? That plus 3. What's that plus 3 tell me I'm going to do? I'm going to move it up 3. So 1, 2, 3. And there's the exact same graph. Cool? Okay. What if I had now f of x minus 2? Well, that would look like x squared minus 2. What would happen to that one? It would go down 2. And again, it would look exactly the same graph. Pretty simple with a translation, a slide. Yes? Okay. The next one, let's say I took f of x and I multiplied it by 2. That would look like 2x squared. Okay. My original was here, here, and here. My new one will be twice as big because it's a stretch. Notice how I took that blue one and basically stretched it vertically. Now, who can tell me why it's a vertical? Well, because it's on the outside. There's no set of parentheses around it. So I know it's outside. How do I know that it's a stretch? Because it's bigger than 1. Are you with me? It's bigger than 1. Okay? How would I shrink something vertically? Multiply it by a fraction or a decimal. Now, see, we might say, initially we'd say less than 1, but negative 2 isn't a shrink. It's actually a stretch and a flip. But we'll get to that later. So do we understand how we know whether something is a translation and how something is a stretch or a shrink? Translation happens by adding or subtracting, yes? A stretch or shrink happens by multiplying. Big number, stretch. Small number, shrink. You with me? Okay. I'm not going to talk anymore about the negative. The negative then would flip it. Okay, for example, last one of this, if I had negative f of x, that would basically be negative x squared. And that would be starting in the same spot and just flip it vertically. Okay? That's what the negative sign does. All right? Now, it's important to me that you're clear with this so far because We're about to put some makeup on and get crazy. The vertical happens just like that. Okay? And those same principles are going to be true when we talk about horizontal. But the horizontal is going to be wearing parentheses. It's going to be wearing makeup. You're not going to get exactly what you think. Okay? Here's what I mean. Horizontal is wearing makeup. It's opposite of what is expected. Opposite of what is expected. So, plus 3, you would think would move right 3. But it doesn't. It goes left. Minus 3, you would think goes left, but it actually goes right. I'm going to give you a second to write that down, and then I'm going to show you what I'm talking about. All right. Here is an example of a horizontal transformation. Notice that the plus 3 is happening inside the parenthesis. Since it's happening inside, we know it's horizontal. Yes? And if we're thinking about horizontal, and we said, hey, where's plus 3? We would think that that would go to the right 3 places, correct? But it doesn't. This is going to go left 3. So the one thing that you have to remember about horizontal is it's always going to be opposite of what you would think it would be. So, to the graph. Parent function looks like this. And x plus 3 would move 1, 2, 3, would look like this. Got it? So, if I want f of x minus 2, it would look like x minus 2 quantity squared. Where is that going to move? 2 units to the right. Cool? All right, so what would happen if I do this? F of 2x would look like 2x squared. Now, we know it's horizontal because it's on the inside, right? And 2 would make us think that it's a stretch, getting bigger, a stretch, right? But it's the opposite, so it's actually going to be a shrink. And it's going to shrink horizontally by a half, or the reciprocal of whatever that number is. Are you with me? So this thing is going to look something like that. Inside. 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 Outside. Outside. Inside. Outside. If I add or subtract something, that's a slide or a translation. If I multiply, that's a dilation. Think you got it? I hope so too. Now, for this homework, I don't care about what's up here. I don't care about that. All I care about is you doing the evens. You don't have to watch anything at home, nothing. All I want you to do is the evens, and I want you to look at it. Let's look at number 19. Number 19, I'm going to show you what I want. That's inside, so it's a horizontal. It's multiplication, so it's a dilation. Come on. By what? By 1/2. If you get all that, I'm jacked. I'm going to look at number 21. What is 21? Vertical, because it's on the outside. It's subtracting 2, so that's a translation down 2. Cool? Now, I want you to do the evens. Okay, and we'll check those tomorrow together. Got it? Well, I got one more thing of homework for you. You got those and read and highlight 2.2 because I need to talk about contextualizing this stuff tomorrow, contextualizing linear functions. I promise you we're going to be talking about rate of change and initial value a ton. Okay, but I need you to go to finish these. You should be able to get done before you get out of here and read and highlight section 2.2 so I can go into that tomorrow. Cool? No. There's what? Just to the end of that page. So there's 3,